Hello, and welcome to a rather ghostly edition of 365 Days. That's the wrong name of the show. Let me try that again. Hello, and welcome to a rather ghostly edition of The Daily Space. For reasons that I've been unable to figure out, both of our webcams have decided that everything is going to be pixelated, dark, and, well, fuzzy. I'm not sure what the issue is. It may be related to using a trial version of our production software. We will be working to fix that by tomorrow, but we decided to go ahead and proceed with today's episode, knowing that the science is more important than how I look. Thank you, Susie Murph. Thank you so much for the subscription. We have dogs in the background, and subs mean dog treats. So let me pull that camera up. You ready? Go get it. So thank you so very much, Susie. Okay, so yeah, I don't know what happened to our video, but we're going to proceed as though everything were normal and discuss all that is new in space science today. Now, in the new but not as sexy as we had last week in terms of rocket launches and rockety excitement, we have news coming to us from the European Space Agency that the Bepi-Colombo mission, which is a joint production of ESA and JAXA and contains two separate Mercury orbiters on board, has passed all of its flight tests. It's currently near the planet Earth, and it is ready to proceed on its many-year journey that will include many different gravitational assists, all in the name of getting it safely in orbit around Mercury. Now, it's gonna be a long time getting there. So taking 5 months to make sure that everything checked out while it was close enough to the Earth to have quick back and forth digital conversations with the spacecraft really makes a lot of sense. This is one of those missions that really demonstrates that space science is sometimes all about the delayed gratification. In fact, the delayed gratification here is they named this spacecraft in 1999. For 20 years, people have been working on getting this spacecraft up and running. It's going to be roughly another 7 more before it finally gets in orbit around Mercury. Now, the complication of getting to Mercury safely is how do you get so close to the sun at a velocity that has you set to stay near the sun? If you go straight into a normal transfer orbit from here to Mercury, you have to essentially slam on your brakes. You put yourself into an elliptical orbit that aligns you with Mercury on its orbit, such that one elliptical orbit goes from Earth at its furthest point from the sun to being at Mercury on its nearest point to the sun. Now, that particular elliptical orbit has you going significantly faster than the planet Mercury when you get to Mercury. And slamming on the brakes is something that would require a great deal of fuel. Rather than expending all of that fuel, this particular little spacecraft is going to, well, borrow some gravitational assists, or I guess accept some gravitational assists from Earth and Venus that will slowly change its orbit, lowering it down more and more circular until finally it is able, without as much of an expenditure of onboard fuel. And in this case, it's not fuel in the contemporary sense. It's using a combination of solar and electric propulsion. So with its solar electric propulsion, it's just not capable of slamming on the brakes. So in a way that it can pull off with this high-tech engine that it has, it's going to get into orbit around Mercury. And they have found a way using orbits to avoid the necessity of carrying a bunch of heavy, expensive fuel and slamming on the brakes. So it's always good to avoid slamming on the brakes, even if you're a spacecraft. So good luck, little spacecraft. You are ready to go and explore Mercury as has never been explored before. Now, the next story I want to bring you is a bit unusual for this show because what I'm currently showing you is the sedimentary layers that are filled with dead fish on a fossilized riverbank in northern United States. Now, this particular, what's called the Tanis find, shows that moment right after the Chicxulub asteroid crater was formed while shock waves were still reverberating through the planet. So this is one of those times where paleontology and astronomy get to work together. As I've said before, in general, every little kid is interested in both dinosaurs and astronomy, and we won because we killed the dinosaurs. And this story right here is your evidence that that happened. What makes this such rock solid, pun intended, evidence of the impact being responsible for killing off all of the land-based above water dinosaurs, some of the flying ones were allowed to survive. What makes this such rock solid evidence is the presence of small glass beads that would have formed during the impact event being embedded in this layer and also being embedded in the stomachs of some of the dead fish. Now, if any of you, like me, have fish, you know you drop pretty much anything in the tank, and some of them are going to try and eat it. This means that my turtle has to fight it out with goldfish to get his food, and it means that some of these very fossilized, very dead fish, well, they ate small glass beads falling out of the sky that formed during that impact. So we have that one tantalizing thing that was like, okay, this is when these fish died because the beads are still in the stomach, haven't been digested and processed out. And the other thing is they were also able to see in the sedimentary layers and how the layers compared to the river channel's original placement, that a lot of these fish got deposited up on the shores around the river during an amazing seismic event. I'm not sure earthquake is the right word when the reason the earth is shaking is it just got hit by a giant rock from space. But to compare it with a standard earthquake, it's estimated that were you to put this on the seismic scales that we use today, it would have been 10.5 or possibly 11 on the Richter scale. This is a logarithmic system, so you go up by approximately a factor of 10 every time you increase in magnitude. Now, that means that this is, well, 100 times, 1,000 times more powerful than the tsunami. Sorry, I did my units wrong. It is 10 times to 100 times more powerful than the tsunami generating earthquake that hit Japan a number of years ago. That was estimated to be roughly a magnitude 9 earthquake. So we're looking at something significantly more powerful. Now, they were also able to see that basically the river would have hit an oscillation as the planet oscillated. So the seismic waves, the compression waves, reverberated around our world. And this is a new mechanism identified for how things died in the asteroid impact. So among the ways that this single asteroid impact killed things on Earth off, we have, first of all, it hit the planet and it probably took out a whole lot of stuff just with that initial impact. You then have a seismic wave you then have a shock wave that is rippling across the planet, throwing dirt, rock, trees, very dead dinosaurs, all up into the air at escape velocities. That material then begins to rain down on the planet, including these glass beads that we just discussed. And while that material is raining down on the planet, we also have passing through the world's crust these seismic waves that were capable of slushing rivers out of their banks. So we had this stuff falling out of the sky, massively superheated the atmosphere, because what comes up when it comes back down? Its kinetic energy gets transformed into heat in the atmosphere. So our planet became an oven. We have all of the material that stayed hovering in the atmosphere that blocked out the sunlight. And now we have fish and things like that getting sloshed out of their riverbanks. And you can just imagine the tsunamis that would have also occurred. So really, we don't want to be struck by a giant asteroid. And this is why we spend so much money on so many different surveys to look for the rock that might want to hit us next. So this is probably going to be one of my favorite science stories for the entire year. And it has one of the least exciting pictures of the science stories we've had this year. But hey, death and destruction. If it bleeds, it leads. Okay, moving on to what is not so much a story as a highlight of what is to come. This is Global Astronomy Month, and I want to bring this to your attention because there are a number of our partner organizations, Astronomers Without Borders, leading among them, who are running numerous events all across the world to get people going outside, looking up, going online, watching amazing presentations. And you can find out more by Googling Global Astronomy Month and seeing what might be present in your area, or by clicking on over to the Astronomers Without Borders website and seeing what all they have listed. There are hangouts, there are YouTube events, there are star parties, there's so much. And this is your opportunity to find other people in your area who may have the same passion for astronomy and space science that you do. And it's always good to meet some people in real life that, give you someone else to go out and do astronomy and talk astronomy with. Now, in more close-term news, tonight we have inductions into the Astronaut Hall of Fame. We will be covering that live right here on Twitch, so put that on your calendar and prepare to come back. Tomorrow, if all goes well, the Falcon Heavy is going to have its second launch and its first launch where it's carrying actual cargo. We will also be bringing that to you live. We are still waiting to find out exactly when the broadcast will begin from SpaceX. We anticipate that we will be starting our broadcast either at the same time SpaceX does or half an hour before launch, whichever occurs first. So follow us on Twitter and keep abreast of what we know and when you can tune in. Now, coming up later this week is a story that has received more hype before it happened of any other story I have ever seen in space science. We all got press notices about a week ago that this coming Wednesday, the Event Horizon Telescope would be releasing its image of the supermassive black hole in the center of our Milky Way galaxy. In anticipation of this, we saw other people pushing to publication their results of radio images of supermassive black holes of, Cygnus A is the one we highlighted last Friday. And today on broadcast station after news station all over the internet, including on NBC and other mainstream stations, the announcement that later this week, we are going to be seeing our first ever picture of a black hole. Now, I'd like to clarify that a little bit. We're not going to be seeing the black hole. We're going to be seeing the black hole's effects on everything around it as captured in radio light. This means that we're going to be seeing how starlight behind it gets bent, any material around it. We're going to be seeing things in unprecedented resolution. And what I'm showing up on this screen is an artists' interpretation of what just might be seen. Now, that's all we have right now is artists' interpretations and theorists' models. Wednesday, we get the real thing. And we'll bring it to you right here on twitch.tv. So that's really all I've got for today, but I will take your questions after I do a brief station identification. My name is Dr. Pamela Gay, and I am here to put science in your brains. Thank you so much. Let me bring up the dog. The dog is coming to me currently, and you all get cute dogs. And thanks for your bits, because really this is the best thank you we know how to give. You want this? Go get it. And there is now Cheerio dust raining out of the sky. Thank you so much. We are part of CosmoQuest.org, your place to learn and do science. We are working on finishing up our website while also working behind the scenes to provide software support for the OSIRIS-REx mission. So we have a lot going on right now. And when we can, we're going to bring you that code creation right here on Twitch. We are a production of the Planetary Science Institute, a nonprofit dedicated to exploration of our solar system, a 501c3 making your donations tax deductible wherever the law allows. We are working in collaboration with Youngstown State University. Now, I have a goal over here. I have a goal meter beside me. This is because we want to pay Annie all the hours she puts in to everything she does on this station. So please help me pay Annie and consider making a contribution at streamlabs.com/CosmoQuestX or by joining our Patreon. Patreon.com/CosmoQuestX is really the best way you can support us. By signing up for a monthly contribution of $1 or more, you're letting us know you want us to keep being here month after month. And we want to keep being here month after month. So take what you'd spend on one cup of coffee you'd buy a friend and help us out. Okay, thank you, Trucker Kev. I'm about to run out of Cheerios, but I have a bag of dog treats, so we will make this work. Okay, so I am now going to look for your questions in the chat. I'm going to scroll backwards in time first. I love that people are slowly discovering all of our new emotes. We have so many cool emotes right here. Yeah, the overlays are clear as a bell, but the video cameras are just borked today. I have no idea what is up with the way the videos are going in. I'm so sorry to hear that you've been sick, Guido. Please get better quickly. Spring is a terrible time to be sick. Hello, fellow hoodlum. Yes, KT Boundary for the win. Scrolling. Oh, Larry bugged out and I didn't get to say goodbye. So AstroWise asks a fabulous question. How do they autopsy fossilized fish to see the glass? It's kind of like how they figured out that cropolites, which are fossilized dinosaur poop, are fossilized dinosaur poop. If you find enough fossils where you see the exact same structure within the point in the skeleton where a stomach would have been, you assume that that clustering of stuff must have been at that point in the critter. So when we see in the area where alimentary canals would have been in a dinosaur, we see the same kinds of fossilized stuff that we see around eggs and things like that. We know that that's fossilized dinosaur poop. When we see clusters of glass beads in the areas that would have been associated with where the fish's stomach would have been, we know that those clusters of beads would have been in the stomachs. Yeah, so basically lay down the thing, strip it out, and just imagine how everything would have been laid out inside the body as it fell through and ended up mixed up in the skeleton. And over and over, they found these clusters of the glass beads in the places that would have been stomachs. That's an excellent question. I really should have brought that up while I was talking. Okay, Hanny's Vorverb asks, would that have been the loudest sound living things have ever heard? Yes. I actually don't know if the shockwave, sound wave would have actually killed things before they heard it. So it's one of these things where if you're close enough to the impact, you hear it and you die. It's kind of simultaneous. Yeah. Ruff's map makes a comment. 14 of the 15 known species of T-Rex come from that same geological formation in the Dakotas, Wyoming, and Montana. Yeah, it's an amazing area on the planet where just the conditions over time have allowed us to access the fossil layers tied to this point in history. What's really amazing about how our planet recycles its plates on the surface, the way weathering and motions have taken place, is we keep ending up with these different niches that are ideal for studying different points in the Earth's history. If you want to see the oldest parts of Earth's history, you look at the Canada Shield and you look at some of the features in Western Australia. If you want to understand the earliest days of humanity, there are places in South Africa where you go looking in caves. There's places in Ethiopia. If you're interested in dinosaurs, the answer appears to be China, Dakota, and Montana. I don't remember the exact region in China. It is a localized area. I simply don't remember the name of the localized area in China. It's just a matter of what's near the surface now gives us a chance to see different windows into our planet's past based on what geology is near the surface. It's awesome and frustrating all at the same time. Welcomes Extreme Couponing Donkey. You have a very long username. Oh man, I have the wrong day for Falcon Heavy. Okay, I'm sorry about that, folks. We're going to have a really busy day on Wednesday. Okay, things keep moving. Astro Hells, you're fabulous. Okay, scrolling. Does the 350 include Patreon? Currently it does, yes. Yeah, that currently includes our Patreon for the month. It doesn't include bits yet. I haven't synced in the bits. Okay. So this number over here, yes, I can do this. This number over here is a combination of the Patreon that we had recorded in the books as of last Tuesday, as well as people who have donated through streamlabs.com/CosmoQuestX so far. So yeah, that's where we're at. I can tell you, well, you guys can look above, I think, and see where we are in terms of bits. I will factor in the bits later today. So you guys are fabulous. Help me pay Annie. And we hate begging. I just want to say that. We just want to hang out with you and make a science. That's all we want to do. This morning, there's a cartoon that I shared out on Twitter. Let me see if I can pull it up to share on stream real fast. That struck a bit close to home. Let me see if I can find it before I say anything, because it kind of speaks for itself. Now, the context you need in seeing this is when we get our PayPal records for donations that you make, they list everything that comes in through Streamlabs as a tip. So here is the comic. It's Non Sequitur by Wiley Miller. And it has someone saying, see, I told you the private sector could take over funding arts and science just fine. And at the table, you have two people. A gentleman in a lab coat with a container in front of him that says tips and a sign that says, we'll explain the difference between climate and weather for tips. Next to him is a woman with a drawing easel who says, we'll illustrate it for food. And as someone who is currently relying on the sale of artwork and income from Patreon and bits on my personal Twitch channel to pay half my income, I just kind of died inside when I saw this. So, thank you though, because we wouldn't be here at all without you. You make it possible for us to, well, for me, I didn't go out and find a software programming wonk job that I hated going to every single day. For Annie, she didn't have to follow her own less than optional options. Well, we are only part-time. We're part-time doing something we love and that matters. You allow us to have a life that I think matters. And to all of you who don't contribute because you can't, oh my God, I'm there. I had to discontinue a bunch of the Patreons that I had when the year came to a close. And I get it. And let's just hang out. Let's just talk science. Ask your questions and give me things to do that I think matter. So thank you all for being here. Are there more questions? Hopefully there's some happy sciencey questions. So M. Sierra Whisk says, how does the data required to make the image of the black hole compare to observations we've already made of the black hole in the center of our galaxy? Have we not already observed the region? So different telescopes have different capabilities, different abilities to see things, different colors that they see in. And the best images that we have right now, in my opinion, and everyone, when you use the word best, has a different opinion. My favorites are the work done by Andrea Getz at UCLA. She's been using the Keck telescope for over a decade now to look at the very central area of our galaxy in infrared, and has been watching stars orbit around the innermost areas of our galaxy and coming to understand, along with her collaborators, what is the population of objects deep down in the heart of our galaxy. Now, that is one color of light and one set of data that only resolves things at the stellar level. Thank you, Veronica Cure. Thank you. Oh, so covered in Cheerio dust. So in addition to that, we also have images in the X-ray that tell us where the gas that has been expelled by shredded objects has gone, or rather where the photons have gone and excited the gas around the supermassive black hole. This particular image is one that's going to be taken, or has been taken and will be released, that highlights how the center of the Milky Way looks using radio light. Now, when Andrea looked at the system in infrared, she was limited by the size of a single telescope. So something that might be the size and diameter of an apartment, a small house, was as big as she could get. And the resolution of an image is directly related to how far apart, left to right, front to back, a telescope mirror is. Now, it can be segmented, it can be in pieces. You can, in fact, take two Meade 8-inch telescopes and separate them by a couple of miles. And if you run fiber optics just right to be able to combine the light from those two telescopes, they will act resolution-wise what size object you're able to discern, like a telescope a couple of miles wide. Now, they're not going to have a lot of ability to resolve faint objects, but they will be able to see bright objects in extreme detail. In looking at the center of our Milky Way, they wanted to collect a lot of light so they could see faint, and they wanted more resolution than has ever been capable before. And so they used a technique similar to taking two meat 8 inches, separating them and connecting them with fibers. But because they were working in the radio, you don't have to connect the telescopes in real time to combine their light. You can actually take radio telescopes scattered all across the planet and above the planet, record the incoming radio signals from the center of our galaxy, combine them later in software, and get an image with a synthesized telescope, an interferometry telescope, that in this case is bigger than the size of our world. This is the first time astronomers have gotten all of the needed coordination, which included having to fly a plane to an observatory in the South Pole to get data back. This is the first time we have coordinated this kind of an observation using so many different instruments on and above the planet. So no, we've never gotten anything like this. We've had amazing studies all across the electromagnetic spectra, wherever dust allowed. Visible light doesn't really get out. But for everything that we've done, we've never done anything like this. So this is going to be the best ever image that we've been able to present. Okay, so let's see. Thank you so much. Okay, I'm just going to take this container and dump it on the dog bed. Come on, Eddie. Come on. Come on. You all get Cheerio dust. You all get Cheerio dust. Cheerio dust for dogs. I will go out and buy more Cheerios. Thank you so much for forcing me to run out of Cheerios. Okay, looking to see what questions we have. Wasn't there a story that the black hole at Sag A star was pointed at us? No, it's not pointed at us. It's pointed perpendicular to us in a lot of ways, which is a fabulous thing. Okay, let's see what else we have in here. I love seeing you guys using all of the new emotes. Thank you. And if anyone ever subscribes at our highest level, we have a helmet that was Max Headroom inspired. So that's all I've got for today. I am now going to go do that onerous task known as getting a new driver's license. And I will be back online later, and we will keep the science flowing. So I'm now going to carry on our tradition of awkwardly rolling the credits, because there's really no other way to do it. And I'm going to find someone to raid. I am, as always, open to suggestions. So if you have any ideas of someone that you'd like to see rated, let me know. Otherwise, I am also looking in the Knowledge Fellowship Discord to see what all is going on out there. The Knowledge Fellowship is a collection of streamers that are all trying to bring education to Twitch. Okay, here we go. EJ is currently doing Addiction Simulator, then Kerbal Space Program, then City Skylines. Okay, so we also have JavaScript with Adam13531. Gladiator fighting is not related to what we're doing. Watchmaking lessons with Chronoglide. I'm going to go with EJ. He's space related. So thank you all for being here. And wherever in the world you may be, you have a sky. And it's the same sky all the rest of us share with you. So remember, we are one planet, one people, trying together to understand one universe. And wherever in the world you may be, Have a fabulous morning, evening, or afternoon, and get outside if the weather allows and see that sky. Bye-bye. You're so good. So good.